We're taking a look at the periodic table and the periodic trends that we see in the periodic table, including atomic radius, electronegativity, and ionization energy. And you know you've got it if you can do three things. First, be able to define these three terms. Second, you can explain the trends as we move down a group and across a period. And third, you can label the periodic table with arrows showing the direction of the trends. And in this video, we're going to focus on the atomic radius. The atomic radius is the size of atoms. It's the distance from the nucleus to the outermost electrons. And it's related to the force of attraction because the stronger the force of attraction, the closer the electrons are going to want to be to the nucleus. Remember, the nucleus is what's attracting the electrons, and it's in the middle of the sphere. So if the attraction is stronger, the electrons will get closer and the whole sphere will get smaller. Now, we're going to be looking at data to try to see what the trend is. And for this, I recommend that you have a periodic table so you can find the elements and see where they are relative to each other. So take a look at this graph, pause the video, and see if you can figure out what the trend is as I compare atoms in a group. So looking at these elements, they're all in the same group, and I have three groups shown: group 1, group 2, and group 18. Remember that a group is a column on the periodic table. So lithium is above sodium, sodium is above potassium, potassium is above rubidium. Altogether, these blue diamonds are elements in the same column. And as I go down the column, I see the atomic radius increasing. Group 2, as I go down the column, I see the atomic radius increasing. Group 18, as I go down the column, I see the atomic radius increasing. So in three groups, it doesn't matter what groups I picked, because this is the trend for atomic radius when we are comparing atoms in the same group. The atomic radius increases going down a group. Each new row is adding an extra energy level, and this energy level puts the electrons further away from the nucleus. So there is less attraction, and being further away from the nucleus means that atom is going to be bigger. Next, let's compare atoms in the same period. Remember, a period is a row on the periodic table. And here I have three periods: period 2, period 3, and period 4. So this is row 2, which goes lithium to neon, row 3, which goes sodium to argon, and row 4, which is calcium to krypton. And I can see that for each of these rows, we start up high and we go lower. We start up high and we go down lower. So going across a period, we see a decrease in the atomic radius. Now, this is because going across a period, we're adding extra protons, but the electrons are staying in the same energy levels. So we're not adding any extra energy levels. Everything in the second row has 2 energy levels. Everything in the third row has 3 energy levels. So with more protons, all of the electrons in those energy levels get closer and closer to the nucleus, making the atom smaller. And that is atomic radius. I mean, it can be quickly summarized using two arrows. As I go down a group, the atomic radius is increasing because there are more energy levels. And I like this picture because you can see those circles showing you the size. As I go across a period, the number of protons increases, which attracts the electrons and brings them closer to the nucleus. So my atom size is getting slightly smaller. And that is our first periodic trend, atomic radius. Deals with the size of the atoms, and it is related to the forces of attraction between the nucleus and the electrons.